4.1 Functions, basic concepts. Now we will see function notation and its representations, increasing, decreasing, and constant functions, and even and odd functions. Now, a function, you can think of a function as a machine which has inputs and it gives outputs. So most of the time in mathematics, the inputs are the x values, and the outputs are the y values, we say. And this here is the rule here, that the machine is always taking the x and putting here this x cube and finds it, and then we say x cube is the y value, and then we give it to out. We give it out. So you can think of the function as a machine, as it is seen in picture. Now, in mathematics, a function is a rule. F is a rule that assigns only one value, only one y value. This is important here. It's only one y value for an x value. So, and we write it as y equal to f of x. So f brings y, or assigns y to x. So here x can be called input, and f of x, or also y, can be called output. The assigning only one y value is important here. So a very good example is the price. In real life, price function. So it's a really nice example of price. So here, think of its price of short. So it's 50 riyal. And price of pens, let's say 100 riyal. So as you see here, there's only one value for each cloth, for one price for each cloth. So one price, only one price for each cloth. What I mean here is this. So you don't say like price of short is equal to 50 and like price of short is equal to 50. We are talking about the same short. Same short. So you see, we don't have this. So we have one price for each cloth, okay, for one cloth. So this is the important thing. This is the important property of functions. And in mathematics, you will check if there are two y values for each x value. So let's look at okay, here is the notation here. F is telling us the name of the function, and this x is the input and the y is the output. We say it's a rule, or you can say it's a matching rule. Also, you can make the matching between x and y. So this is the rule here. F takes x and matches to y, and what's the value of y? Y is equal to f of x. Now there are some different representations of functions. Now the first one is using ordered pairs. So you can write the rule between x and y values by listing the ordered pairs. So here, if it is given f equal to the set of 1, 2, the ordered pairs 1, 2, 2, 4, 3, 4, so it means f of 1 equal to 2. F is 1 and 2 are matched by this function. So f of 1 is equal to 2, f of 2 is equal to 4, and f of 3 is equal to 4. Now this is a function, but note that, for example, look at here. This one is, they're not same as this one. They're not same as this. So this is a different one, and this is not defining a function. Why? Because here they're assigned to this different y values. You see f of 1 is equal to 2, f of 1 equal to 4. So this doesn't make a function. No, it's not a function. Not a function. Because, you know, like the prices, you know, the price of one thing cannot be two, okay? Like you don't have two prices for one item. You have to have only one price for each item. So this doesn't make a function because 1 is assigned to 2 and 4, which is not wanted in a function. Now, another way is to write the equation between x and y, to write an equation between x and y. And look at here, this one, y equal to x squared plus 1 specifies a function. So it means when you put a number here, you can get the value y. So for each x value, you get one y value. So it's a function. So here, if an equation is given to you, you can write it as y equal to f of x, and you can write here this part as f of x. So this equation can be written as f of x equal to x squared plus 1. Simply change y or replace y with f of x. Here is the question. Do all equations specify a function? Do they make a function? No. Not every equation defines a function. So look at here, y squared equal to x does not define a function because when you assign x equal to 1, like x equal to 1, look at this one. So how many values are assigned to x? So you see, when x is 1, this equation is assigning two values for x equal to 1, two values. So here 1 goes to 1 and minus 1. So two assigned values for x equal to 1. So this is not accepted. So this equation does not make a function. So if as a question, if there's a question like, hey, which equation or this equation does it make a function, you can directly look at the y values here. Like if you have y equal to some function of x, so this is definitely a function. But if you have such thing, so for each value here, if you have two y values, then you can say it's not a function. Now another way is to give the functions in terms of a graph. So remember this, remember that a graph is a collection of ordered pairs or points, and some graphs define a function, let's call it f, such that f of x equal to y. Look at here, so you can tell, we might have this distinct points, or it might be given to you as a line, or it might be given to you as a curve. So what is the function doing here? The function takes a value here, the x value, and brings it to a y value here. Okay, so for 3, we have the matching 4. Okay, 4 is assigned to 3, and 2 is assigned to 3 is assigned to 2. And if it's a curve, and for each point, you can find the relation between x and y for each point. So 1 goes to, for example, here, and 2 goes to 2, you know. By looking at the graph, you can tell which point is assigned, which x value is assigned to what y value, or what. Okay, now let's look at here. This here, if you say this is the graph of f, if you say y is equal to f of x, this is the graph of it. So here we say f of 1 is equal to f assigns 2 to 1, and 2 to 2, 3, f of 2 equal to 3, and f of 3 is equal to 4. We can write it this way. Now the other, one question: does every graph represent a function? No, not every graph represents a function. So how will we check it? So we will check it by using the vertical line tests. So what is vertical line test? The vertical line test is this. If there are no vertical lines that intersect the graph of a graph, let's say a graph at more than one point, then this relation is a function. Now let's look at here. Here is the idea. So look at this graph, and here take this point. So there's this x value, x equal to a. So for x equal to a, then we have two y values. One on the graph, this is b, it goes to b, and it goes to c, right? So for x equal to a, we have two y values. Right? They're both, I mean, AB and BC, AC are on the graph. So this doesn't make a function, okay? And a function, you cannot have two y values for one x value. So the test in itself, as briefly, it's this: make a line, and if you see any 2 points intersecting, if the intersection of the line, the vertical line with the graph is 2 points at 2 points, then you say it's not a function. So this is not a function. Now look at the following example. Determine whether the following graphs define a function. Now to check the function, you have to look at the vertical lines, and if each vertical line is passing through or intersecting the curve at only one point for each of the vertical line, then it's a function. So as you see, each vertical line is intersecting the graph at only one point. So for this reason, it's a function. So look at here. Here you take this vertical line, and you see we have two intersection points, and you can automatically say it's not a function. One thing, one difference is, like, to say a function, it's a function, you have to check all those vertical lines. We have to make sure that all vertical lines are intersecting the graph at only one point. But to show it's not a function, it's enough to get one vertical line with 2 points, intersection 2 points, that you can directly say it's not a function. Now look at here, look at this function. You take the vertical lines and check all of them. As you see from the graph, all vertical lines are passing through, intersecting the graph at only one point. So you say this is a function. Now, how to evaluate a function? So from now on, we will give you the functions, or we will see most of the functions in this form. So f of x will be, the rule of the function will be given in terms of a formula. And we will say f of x equal to x minus 3, which means when you take an x value, you put it here, and it will give you the y value. So here is how to evaluate the functions. We basically replace x with the number. So f of 1, for example, f of 1 is wanted, so x is changed by 1, replaced by 1. So x should be replaced by 1 here also. So the rest is same. So all x's should be replaced to 1. So you got minus 2. So we say f of 1 is equal to minus 2. This is how we evaluate a function. Now let's look at this example. The function is given this way with this formula, with this equality. Let's say f of x equal to x squared minus 1. So how to get f of 1? So you write here f of 1 equal to 1 squared minus 1. I recommend all the time you put them in parentheses when you're replacing x with some number. Here on this side, you put it parentheses, because there will be also minus values here. It's better you put the parentheses. So we do the same thing here for 2 squared minus 1, so it's equal to 0. This is equal to 3. And now when it comes to 3a, so we have the same issue, x, 3a. So you write here 3a squared minus 1. So this will be 9a squared minus 1. And for a plus 1, we have the same thing. We basically take here, okay, let's do it, a plus 1. So here x is replaced by these two terms here, a plus 1 by binomial. So you will replace x with a plus 1. But as I said, when you replace it here on this side, you write the input in parentheses so that you don't make a mistake. So if you have the parentheses, you take the square, and we know it's equal to a squared plus 2a minus 1, and then there's the cancellation, so we end up with a squared plus 2a. F of a plus 1 is equal to this. So the rule in evaluating functions is whatever you see for instead of x, I mean, for example, you instead of x, you see here the smiley, then you have to put the smiley here for x. See x, and x is changed with smiley, you put the smiley here also. Whatever you see for x, it might be a very complex expression, it might be anything, you have to replace with the same thing here on the right hand side. Now, domain of a function, we can look at some, some functions can be given this way, like 1 over x, f of x equal to square root of x, and some other algebraic operations. We can write lots of many function types and functions, but look at this function. This formula will work for some x values. Like some x values, I mean, for most of the values, it will give a good number. Like for example, 0.5 here, it will be like 2, so it's a good number. I mean, the good number means like the real number. It's a real number, and you put this f of minus square 2, you got like minus or square 2, right? So, but it might not work for all values of x. For example, look at your f of 0. 1 over 0, it's undefined, So you say this function, this f of x, 1 over x, does not work for x equal to 0. Or you can say f doesn't accept. So f doesn't, or you can say f doesn't accept 0, right? Or you can say this, or you can say that. Okay, or you can say f of x is not a real number for x equal to 0. Now look at these two examples. Look here, this 1 over x minus 1, 2 is okay. You can put 2 here, you can put 3 here. But if you put here 1, then there's a problem. F of 1 is undefined because 1 over 1 minus 1 will be 1 over 0, so it's undefined. So as you see, 1 is cannot be a value of x, so it cannot be accepted as an input. So look at here the square root of x. So look at here, you can put 0, you got 0. So what about this f of minus 1? Square root of minus 1, it's not a real number, right? Not a real number. So in the same way, you can try the other negative numbers. Same issue. And if you get, if you go for -3, you will get the same thing. So which x values are accepted by this function? It is clearly the positive numbers and 0 are accepted. Okay. Now let's come to this accepted values. So the domain of a function means the set of the set of the numbers a such that f of a is the real number, or I can say set of the x's accepted by, or the set of x values accepted by the function. You can say this one for the domain, or you can say, in other words, you can say the domain is the set of inputs or the x's accepted by the function. Now look at here, this when you look at this function here, you see 3 not accepted because it makes it 0 here, the denominator, and 4 makes it 0. So we remove, we can say the domain is all real numbers except 3 and 4. In interval notation, you can say the domain is this. So this is minus infinity 3 not accepted, 3 not accepted, 4 not accepted, but all the values between them accepted, and then union 4 to infinity. And now look at here, you say the domain of f of x equal to square root of x is all non-negative real numbers, so in interval notation 0 and the positive values. So when you put negative values here, they're not accepted. Now, let's determine the domain of g of x. So look at this function and try to see which type of, which x's will be accepted for g of x. So you can try to find by listing them, and this is not what I want to do. I mean, you can check like f of 0, I mean g of 0, what is this? Let's put it here. 0 minus 3 times 0 minus 4. So is it a real number? Okay, let's see. Okay, minus makes plus. So we got 1 over square root 16, 24, 20, square root 12. So it's a real number, right? So this is a good real number. So 0 is accepted, right? 0 is in the domain. 0 is in the domain. And what about 3? So if you want to say this G3, so when you do it, you will get 0 here because it will make this one 0. You got 1 over 0, and this is not a real number. It's undefined. So it's undefined. So then you say 3 is not in the domain. Okay. The question here is this. We cannot go one by one. Okay, you cannot go like check like 0, 1, 2, 3. You have to make a very comprehensive approach. So can you put some condition on here? So because of the square root and because of 1, it should be like, because it's the fraction, it's the makam, it's the denominator, this cannot be 0. And because of the square root, it has to be bigger than or equal to 0. And with, okay, this not equal to 0 and bigger than 0 or equal to 0 means, when you combine these two, you get this condition. So if x is in the domain, it has to have this property. So in this case, okay, we can say if it's bigger than or equal to 0, this one here, the inside, this term is bigger than 0, then gx is a real number, it's accepted. So now we have to find the set of the x's satisfying this inequality. So it means we have to solve it. So how do you solve it? You find the points here. So x minus 3, set them equal to 0. And then you find the points x equal to 3 and x equal to 4. And then after this, you do the sign, the real line. You make the real line and make the sign here. You test the points here, like put 0, and you will find it's plus 12, so it's plus. So you put 3.5 here. You got 3.5 minus 3. Okay. Anyway, for x, you put 3.5, you will see it's negative 0.25. You can check it. So you will get negative values here on this interval, and in positive values you can take 5 and put it here, 5, 5, then it will give you a positive number. And you will get the sign chart. The sign chart will tell us the positive parts, the positive intervals we are looking for, positive parts are those parts. And 3 and 4 is not included, so we have to write this way. So 3 and 4 is not included because there is no equality here. So the answer will be, and the domain will be minus infinity to 3 union 4 to infinity. So this domain issue is important, and this is how we use the inequalities here. We learn how to solve the inequalities and we use it here. So determine the domain of this. So again, it's the same type question. 1 over, since it says 1 over the x squared minus 1 cannot be 0. And because of the square root of this x squared minus 1 should be bigger than or equal to 0. But because of a reciprocal, this makam or denominator cannot be 0. When you combine them, we got this condition here. So we can say this one, the domain of G, the accepted values for G is equal to set of the x's such that x squared minus 1 bigger than 0. So then we have to solve this one. So x squared minus 1 bigger than 0. We'll solve it. Okay, this is in standard form. The next thing we do is, if you remember, you find the solution of this equation. It gives you x equal to plus and minus 1. And the other step is to put this minus 1 and 1 here, the roots. And then the next thing is we will take numbers and we will check the numbers here, like let's say minus 2, and plug it here. So put it here, you will see it's plus. And now take 0 here, x equal to 0, and plug it here. You will see minus 1, which says it's minus here. And take this one here, x equal to 2, and plug it in this equation, in this term here. You got 3, it's positive. So then we got this one. So we have the sign chart here. The sign chart is like that. So we have these two. Okay, now we want the positive intervals and we don't want the roots. So positive intervals wanted, but because of there's no equality here, so we say but not roots. So these roots are not wanted, so you write the domain as, now domain is minus infinity to minus 1 union 1 to infinity. So this is the domain of G. Now the range of a function. So range of a function is the set of values that f of x takes, not the x's, but the f of x's. So it means range of f is the set of outputs or the y values. You know, x goes to a y value, and this y value is indeed equal to f of x. So we are talking about the set of this part, y values. Now the only way to find them is like to put for each value you find this f of 1, f of 2, you know, put all the values here and find the list of the values, then you can have an idea about the range. But okay, we will not, it will take a long time, so for this reason we don't directly ask it this way, we just use the graphs. So how can you tell the domain and the range from the graph? So when the graph of a function is given, the domain and range can be seen as the projections of the graph onto the x-axis and the y-axis respectively. Okay, if you didn't understand this one, wait a minute. In 30 seconds, I think you will see it. I will show you in the graph. Now, state the domain and range of this function. Now, this is a function. Let's say this f, x, and y values are matched by this rule. -1 is matched with 2, like 0, 3, 1, 5. And b is it's another function, and it has this type of matching. And this is a graph of this is a graph of function, and this is another graph of function. Because of the vertical line test, you can say it's a function here. So we have only one intersection for each vertical line. Now you see them. Now these are all functions, so we have to find the domain and the range. Okay, keep this in your mind. Domain is the set of x's. So the set of x's here is -1, 0, 1. The set of y values 2, 3, 5. So it's clearly okay. Here also the set of the x's are 1, 2, 3, and the set of the y's are 7, 8. You can say this is the domain, the set of the x values. This is the range. Okay, let's see. It should be written here. Now, domain is the set of the x components here, you see. And the range of the set is the set of y components, 2, 3, 5. And do the same thing. The domain is the set of the x's, and the range is the set of y's. Now, this domain is the set of the x's. So look at these points. So you will find their x components here. Look at these points. You will find the x components. So how many x components you see here? You see all x components, like all the values on the x-axis are the x components of the points here. They are matched by a y value. So they are the domain. So these are all accepted values of the function. So you say the domain here. Okay, by the way, you can take the projection here as I did. You can take the graph and make the projection of it onto the x-axis, and you will get the whole x-axis. So you say this makes the domain here. So what's the domain? Domain is -infinity to infinity. And for the y values, you do the same thing, but this time you will project the points on the graph to the y-axis. Now, can you tell the set of the y values corresponding to the graph? So you say it's from 1 to infinity. So 1 is included because we have a point here corresponding to this value here on the graph. So look at here. So for the domain, you have to look at the projection of the graph onto the x-axis, which makes -1 to 1, and they're here closed. You say it's -1 to 1, and this makes the domain. And when you look at the range, take the projection of the points onto the y-axis for the range. You can take from any points, like you can choose all points. If the graph goes like this, you have to do more, okay? But here anyway, it doesn't go this way, so it ends here. So which y values do we get here? This part is now, this set is our range. So range will be 0 to 2. And here these points are full, so this 0 is included, and this point is also full, so this is included in the range. And I think this is an extra question here. It was not there. So look at this function that you can tell the inputs here: 1, 2, 3, -3, -2, -1. So these are the domain. And the y values, corresponding y values, will be the range. You can tell the y values. Now, increasing, decreasing, and constant functions. Now, we have, okay, increasing, decreasing, their definitions. We have a mathematical definition for an increasing function, and we have its graph. So visualizing the increasing function, I mean, it's easier on the graph. So mathematically checking this condition, it's hard, and it requires some experience and more detailed knowledge. So it's better you look at the graph of the function to see if it is increasing or not. So it means increasing, it means going up. So from left to right, is it going up? Going up. Increasing means going up. Increasing, it means going up from left to right. Okay? So yeah, decreasing function means f of a will be bigger than f of b for any a bigger than a less than b in an interval. So in visually on the graph you will see this decreasing. So b is bigger than a, and then f of b is less than f of a. So it's this condition satisfied. But visually from left to right it will go down, down. You see going down means decreasing. And there are constant functions. When we say it's a constant function, it means for any a, b value, the output doesn't change. So it means for any value, we have the same y value. The output is same. So we write generally the constant functions as fx equal to c. So it means when you put 1, you got c, 2, c, 3, c. C can be any number here. Okay, but just one fixed number. So as you see, the graph of the function does not change. You see, no increasing, no decreasing. Now determine the intervals over which the function is increasing, decreasing, or constant. From the graph, it's easy to see. Look at this part. Okay, always keep in your mind, this is important. From left to right, you will check the graph from left to right. Not this way, but you go this way. Now here we go this way. What do you see about the graph? So it's going up. So up to here, up, going up. Now here, up to here, so it's going down. And after this one, it's going up again. And now it doesn't change it. It doesn't change here, it's flat. So you say it's constant here. So you can directly say for the ups, you say increasing. For the downs, you say decreasing. And for this part, no change, so it means constant. Now we can write them. We can write what we have seen here as this. So the function is increasing on minus infinity to -1, and we generally use this not bracket but the parentheses here, the curly parentheses, and then the other increasing part is here. So we say it's union 0 to 1. So this is the intervals, or these are the intervals f is increasing on. And now the other one here is -1 to 0, so it's decreasing. And for the constant function, it's 2 to infinity. Now, even and odd functions, now here are the definitions of them. if a function satisfies this property for all x values in the domain, so then f is called even. So if it's an even function, then the graph of an even function is symmetric with respect to y-axis. So it is kind of normal, because when you look at its graph, the y value corresponding to negative x and x are same. So it means if this point is x, y is here on the graph, then minus x, y should be on the graph. So any point here, any point should be there. So you have something like the symmetric. So with respect to y-axis, it has to be symmetric with respect to y-axis. So the other one is odd function, and odd function has this property: f of minus x should be equal to minus f of x for all x in the domain. So if it happens, in this case we call it odd function, and the graph of odd function is symmetric with respect to the origin. You can see that here. So if xy is here, like f of x and f of x is here, so this is the graph, this is one point on the graph. And now then look at the minus x. So if it's symmetric, then its reflection with respect to origin should be here. If it's symmetric with respect to origin, then this f of x should be minus f of x. But also this has to be on the graph, so this is equal to f of x. This should be equal to also f of minus x. So this one here is telling you, this property is telling us the function is symmetric with respect to the origin. Now this is what I told you. This is f of x, and if this is the reflection with respect to the origin, then this f of negative x should be equal to the negative of f of x. So this is what we have in here. Now, how to check even and odd functions? You check them. Okay, for the odd function, you check this equality. For the even function, you check this equality, and for both you have to check both. Okay, and it might be okay an even function. In this case, this will happen. Now here in this example, our function is given. This is given to you, so f of x equal to x. Now you will check if this happens or not. Now you write first f of x, you write f of minus x. Then you check this. Are they like f of minus x? Is it equal to minus f of x? So when you check them, look, I will show you f of minus x is minus x for sure. And minus f of x is minus x again. Now they're same, so you say it's an odd function. Now for the even function, we have, okay, look at the graph. We have to check this one. Now what is given to us is the function is given to us first, and here it's x squared. Okay, the graph generally not given here. This is we don't give the graph. We just give this graph is telling you the symmetry here, so we don't need this one. This will be given to you and asked. You will be asked to find if it is whether it's even or not. So for the evenness, you check f of x and you check the f of minus x. So then when you calculate f of minus x, you will get x squared, f of x equal to this minus x squared is equal to x squared. So you get f of minus x equal to f of x. Then you say it's an even function. And if you're not checking, I mean, if you are checking for any evenness and oddness, you have to check the f of x, then write f of minus x. Here, this first you have to be given the function here of 2x minus 3. So this is our function here. Sorry, this is f of x. So then you check f of x, f of minus x, and minus f of x. So if these two same, then we say it's even. So they're not same, so not even. So these two are same. If these two are same, you say it's odd, but they are not same, so not odd. So in this case, you say not even or not odd, so it means neither of them. Okay, guys, if this part is a little complicated, if this is you got confused, look at the other examples here. I mean, I will show you. Now you will understand what's going on. So please follow my way, and this is very safe method here I'm using. The question is determine whether each function is even, odd, or neither. Now, the first thing for this one, okay, let's do A. This is how I do. Write f of x first. Then write f of minus x. And be careful when you're doing it, x is replaced by minus x, and I will write all the time in parentheses. Okay, the negative here, but the fourth power, so it will come again to x to the fourth. Now minus f of, okay, before doing the last one, I mean, you will also check this one. But before this one, it's better you check these two first. So are they same? They're same. So in this case, you say f is even. So if it is even, then you don't check the last one, because f cannot be both odd or even. Indeed, there's only one function. It can be odd or even. This is the function 0, but this is just one function, and we really we never see it anywhere. So f cannot be both even and odd. Here we got f is even. Now b, so we got this one even, and we stopped. Now for b, we do the same thing. X cubed plus x minus x will be here minus x cubed and minus x. Now check, are they same? Not same. So you say a function is not even. If it is not even, it might be odd. So let's check for the oddness. So for the oddness, you write minus f of x, then it becomes minus x cubed plus x. Okay, please, when you have minus here, please try to, and you have more terms here, please write them in parentheses. This is one of the mistakes that most of the students do, and this gives a wrong answer if you don't put the parentheses here. It will be minus x cubed minus x. So are they same? Yes. So you say f is, so they're same, it means f is odd. So you say f is odd. Now let's look at C. Let's look at C here. Now let's use the same thing here, like f of x equal to x squared plus x. You write this one. Okay, I will use this part because I need some space. Now you write f of minus x. It gives you x squared plus, okay, this is minus, so I will write here minus. Are they same? Not same. You see, there's minus here, there's plus here, not same. So you say f is not even. Now you check the last one, minus f of x, and which is minus x squared plus x. Please put it in parentheses, this is important. Now then minus x squared and minus x. Are they same? So look at here. Look at this part here. Minus x is okay, but we have x squared here, and this is minus x squared. They're not same. So we say we say they're not same, not same. So f is not odd. So we say neither of them is true. Okay, neither is them is true, neither even nor odd. Let's look at the other one. Okay, here is the, we'll see what is given here in the slides. This is exactly what I did. You can check most of the slides. Now let's determine whether each function is even, odd, or neither. We can check this one. Hey, let's do this again. Okay, please, you can stop the video here and then you can try to do it by yourself. Then you can check your solution with mine. When you compare the solutions, so f of minus x equal to 2 minus x cubed plus minus x to the fifth, so which makes 2 times minus x cubed and plus minus x to the fifth. So you see that, right? This fifth power is minus and minus, so I got this one. You can write here minus 2x cubed minus x to the fifth. So are they same? So as you see, they are not same. So you say f is not even. Now the last thing is, okay, if you don't have even, you might get maybe odd. Check the oddness. Like you say minus f of x and write 2. Sorry, this is minus 2x cubed plus x to the fifth. That gives you minus 2x cubed minus x to the fifth. Are they same with, okay, these two, are they same? Yes, same. If they are same, you say f is odd. So you got this one, odd function. Now let's look at the other one. We do the same thing here. We check f of x, f of minus x, and minus f of x. So let's check this one. Okay, now each time the function changes. Okay, here the function is this, and here is the other function is this. So we will use this one in part B. So this is also a making problem. Sometimes some students, they take the first one for the second one, so it makes a problem. So f of x, and now f of minus x. Minus x to the sixth, minus x to the fourth. So you got here minus sixth power, so it's positive. Now negative fourth power, so it will be positive. So you have minus, so you have minus x to the fourth. Now are they same? Yes, they are same. So since they are same, you say f is even. So if f is even, no need to check the others. No need to check the third one. So f is even, you say. Okay, thanks.